or not. It's the pin. I don't think it's the pin, but that there. Okay. Before I get started, quick comment here. Facebook. Other account. Actually, I can see it here. Okay, I put a, what did I do? I put the lecture for yesterday up twice. I thought I put it up when I got done encoding it, then I didn't see it, so I put it up again this morning about, what time was I up this morning? So 6 hours ago, so I put it up twice after yesterday's lecture, but I also put in a link to a website on a formula on compound interest. And I just kind of put a note in there, something to look at before next week. As I said, you're going to be asked to write a program, something similar to the example that we did that was in class, the one on compound interest. Oh, well, that's interesting. One of my pins. The OneNote function works on it. That's the brown pen. That there. So, okay. Well, regardless, I suggest that before next Tuesday, because like I said, I'm going to basically next Tuesday, we're going to have an in-class test. So let everyone know that there. I'll put something up on Facebook that there's an in-class test. Then there's a formula here on the site right here. And you'll notice that the future value of a series is equal to, and they talk about, and they give an example of if we deposit $5,000 into a savings account, annual rate 5%, annual deposits, and they give a pretty good example of what. And you might find what I would do on a test question is, I may ask you to calculate how much money you'd have in the account at the end of 10 years, 5 years, 20 years, that type of thing. Something similar to that there. This is one example, and what they're saying is that if I put $5,000 in, and I put in $100 a month, or that there, at 5%, at the end of 5 or 10 years, I would end up with $23,000 right there. So if you can imagine if you did this as a young person at 25 or 22, after you're married, and you do that till you're 55, so you do it 30 years, you can see how much money you would have right there. And I'm a huge believer in it, and I've done it myself at there. So, I won't say how much mine has grown to, but it's more than 23,000. I can guarantee you that. That there. So, okay, that there. So that's on the website. That there. And again, a reminder, everyone, that there. In fact, I just shut that there. Facebook right here. Why don't I hit Facebook right there. If we overflow this room, we'll seal the room down the hall for that there for computers. So that's just kind of a reminder for everyone that there, just so. as I look in this room, I see 6 out of, I think there's supposed to be 35 people or something like that. As I recall, when I looked at the attendance roster, which I don't necessarily take attendance, there's, I think, more people than there are room seats in this up there. I know that's true in my other class, so up there. Okay, let's jump into chapter 5 right there. And slideshow from the beginning. And let's see. Brown pen works. Blue pen works. All right. Yesterday, neither the brown pen didn't work. So, or I guess it's more burgundy. So don't ask me what changed. Well, actually, my computer did an update last night or this morning. So maybe there's something with Windows Update that changed it. But there was an update. I recall when I got up this morning. It came outside about 4:30 or so. That my computer did an update. So now both pens work. So I don't know whether it's pen or Windows. Okay, here we're going to start talking about writing functions. We've been using functions. That there. C is based on functions. That there. Matter of fact, you've all been, every program that you've done, you write a function and the name of that function is called main. Main is a function right there. So there's a whole list of things here in this chapter. We're not going to, I mean, as you look at this list here, this is actually a relatively short chapter to cover that there. So most problems, I don't know how many slides are in this chapter. Disregard 204. Wow. Yeah. Well, we're not going to be spending a lot of time on some of these up there. But the whole idea of computer programming is they call this divide and conquer. You can call it modular programming. You can call it object-oriented. But the whole idea is that you break your program into smaller pieces. And I've already talked about that in terms of, you know, you're going to rebuild the engine. You know, first thing you have to do is remove the engine. But before you can do that, you have to take the hood off. You have to unbolt the engine mounts. You have to lift the engine up. Actually, you probably should put something under the car, you know, or just support the engine before you actually unbolt it. Although there was one case where I've heard the story of someone removing the engine by lifting the body of the car up, but that's another story. But the whole idea is that you do things in smaller pieces, right there. So when you write your initial pseudocode, one line of pseudocode could represent a function call and actually represent 100, lines of code. So I may have a line in my pseudocode input employee information. Well, inputting the employee information might be a call to a function that reads a record out of a file and puts everything in the employee record file, or the variables that they're. So here we're going to be looking at how we write our own functions. Functions are used modularized up there. Now, there's a whole bunch of functions that come with C. And we've already talked about one in that example yesterday called power, right? POW, that, where if I want to take 3 raised to the 20th, I would call power 3.20. And that will return a value. So power is a function call right there. And it's in the math library. And there's ones for sines, cosines, tangents, half a dozen others. I'm just drawing a blank right there. We can take strings and convert them all to uppercase or convert them all to lowercase. That's there. We can do, we've been using scanf and printf. Scanf, of course, we changed the variables, so we pass it addresses. Printf, we don't have to, we're not changing it, so we just send the values. So we'll talk a little bit about that, including, doing function calls with reference or by value. There's two terms, and we'll get into it. Oh, but someone else is up there. Okay. I was about ready to shut my phone off. That's there. Mine's got a different ring than that, but when I hear a phone, I instantly look for mine. I don't know why. It's just we're pre-programmed to do that. And it's actually quite dangerous, especially if you're driving. You hear your phone ring, and first thing you do is you want to grab it and see what it says, right? And about that time you do that, you hit the woman walking across the street in a shopping cart So I connect mine to a Bluetooth on my car so that I don't do that. But I know other people that actually put their phone in the back seat in their bag. That way that they're not tempted to look for it right there. So okay. One of the things I talked about is avoid inventing the wheel. Inventing the wheel is, again, we're using standard functions in the library or in another library that you have access to. You can do a search on the internet and you can find people that sell C libraries to do all kinds of things. There's companies that hire programmers to sit down and to write functions to do all kinds of, design FIR filters where we pass it various functions, to do circuit analysis, to do all kinds of things where we can call. And we'll see more of that in MATLAB right there, these function calls. But again, when I was at General Electric was the one who did this. It's now British Aerospace. They bought them out. But they were really, really big on every function you wrote went into the corporate library. So whenever I wrote a function, I had to have it match their prototype template. In other words, it had to be a certain format, it had to be commented a certain way, and it had to be written a certain way that they could suck it right into the corporate library. And I actually worked on a project for about 3 months for them that the core of the project was scrapped not because it was a bad project, but because of a manager that was later fired didn't like the concept to begin with. So after I left the company, I went back. It was a contract when I left the company, went back to teaching full time. He scrapped the program, but as it turned out, all the functions were in the library, and as soon as he was fired, they resurrected. He deleted all my code, but all my functions were there, so they were able to redo the project in about 3 days. They were able to get the entire 3 months worth of work back up and working because all the functions were already there. So all they had to do is rewrite the main program, because the only thing he could delete was the main program, because everything was in functions, and those were already in the library. So as a result, it was a very easy fix. So that's one of the reasons you'll see that why we write things in functions is that often these functions can be reused by other people So using functions make that there. Okay, this just says we've already done it. We're going to say we're going to learn to write our own So these are user-defined functions, and we make a function call right there. And we'll end up the day with doing a function call right there. Matter of fact, you could use a function to say do that calculation in a separate routine, for example. Right there. Functions are invoked So the boss or the calling function asks and again, this is kind of the analogous Dr. Tyrell is the department chair. He assigns instructors to teach classes. And he kind of steps back, and then at the end of the semester, we submit grades. If it was that easy, I probably wouldn't be looking at retiring so soon. But that's the way that I always did it when I was the department chair. I mean, we always submitted grades and some samples of student work, and that was it. But will we ask people to perform a task. So, I'm a boss and I assign an employee the task of going to Joe Harbor Road to install a generator at there. So I as a boss am the main, and I just assign someone else to go do that there. So the example is printf. I send printf some information. I have the formatting string and all the variables, and then printf is a function in the library that actually does the printing. Now the key thing is that printing is different on different pieces of hardware. The way that I do printf on a Windows desktop computer is different than the way I would do printf if I'm doing an 8051 project where I'm connected to an LCD. But in my main routine, I call printf. The code behind printf can be completely different depending on what the hardware looks like. I have, 3 computers, that I kind of connect to my computer monitor and keyboard and mouse from time to time. I've got my main Windows machine. I've got a little iMac Mini that I use from time to time. Then I've got a Raspberry Pi. They all 3 use totally different operating systems. They all 3 have completely different types of hardware to talk to the screen. But I can write the same program and run it on all 3 machines. Because the library and the compiler for whatever hardware I've got contains the code for printf and scanf right there. That's in the library. So again, the boss doesn't know how the worker performs this designated task. So that's kind of now that kind of goes, against the Dr. Tyrell sends me to teach a class, and he doesn't know what I do in that there. But again, when I send someone to the generator, install a generator, depending on the individual and the type of job, I don't care how they install it. They can do it at 3 in the morning while they're, they can hook up one set of wiring different order than they do the others. As long as it's working at the end of the day, I don't care. Right there. So I don't want the details. The worker may call other worker functions. So a function can call a function. Right there. So I send employee X down to install the generator. He brings along 2 assistants, and he gives them jobs to do. Back at the main office, I don't care who does what. So this worker, he doesn't, this worker, supervisor, for example, with a crew of 3 that install this generator, he assigns tasks to each of the 2 sub-workers right there. So so it's one of those types of cases that they're, so here is an example. Here's a boss. Here's my worker that's in JB installing the generator, and he's got his 2 assistants right there. And up here at the top level, I don't want to worry about what the assistants are doing. But back when I was in the Air Force, we had what's called the chain of command. At the top of the chain of the command would be the base commander, usually a colonel or a general. Then there would be the squadron commanders that's there, and then there would be the flight commanders, and then there would be the individual squads that we would have up there. So the less the general knew about what the airmen and sergeants were doing at the bottom level, the better, because the only time they got involved is if there's trouble right there. So now if worker 4 gets hurt on the job, then of course the boss needs to be notified that there's been an accident and there's something that needs to be done. But generally, you try to hide from the boss as much as you can. right there, and good programming right there. You don't want to get into the details right there. Now, the sign of a good leader is the idea of delegating the work to his employees or her employees, and standing back and letting the employees do their job. Right there. That's a management skill. That's not a programming skill. That's a management skill, but it applies true for programming, right there. If I'm a good manager and I've got good people, I don't have to attend their classes to see whether or not the lecturers are covering the material. I don't have to have them submit reports every 2 weeks and of everything, that they're, you trust your employees that they're going to do the job and you stay out of the way. It creates a whole lot less work for everybody. But if I have an employee down here that is a screw up and it's going to cause trouble, then the boss always has to get involved, then there's a problem out there. So that's when I say it's time to get rid of that employee. There's a family member that has a maid that is causing all kinds of stress for my relative here, up to the point that my relative was in the hospital because of high blood pressure because of arguing with the maid. And of course I have the easy answer for that is put the maid on a plane back to Medan and do without a maid if it's going to cause you that much stress. That there. So, and that's the thing with employees. Now with programs, if I got a function down here that's not working properly, I need to get in and fix the function. But at the top level, I should not worry about how functions work. I should only worry about what goes into the function and what comes out. What's inside the function should be hidden as much as possible. So math libraries, they talk about these again. They give another example where we pass the square root. We're calculating the square root of 900. So we're doing a call right there. We have arguments and we have return values right there. Now that worked a minute ago. Now it's going backwards. All right. Here's my function right here. And we pass it a bunch of arguments. And these are usually the name of the function, and here's my list. In this particular case, I've got 3 variables. So I call this right there, this has got a name right there. Now this is going to return back something. Right there, that there. So that's the normal way that functions are called. And when we look at main, I put void, main, and void right there. And here's my main program. Well, when I use the word main or void, what did I do here? That there, void just simply means that I'm not going to return anything and I'm not passing anything to it. So void is that there. But if I'm going to say call the sign, I'm going to pass it 33.96 right there. This is an argument that I'm passing into the sign function. Sign will take this and it will return back a value, which I will set the value is equal to the name of the function right there. Right there. So that's the normal way of working at that there. So, the header that there include math.h. We've talked about that last time, that before you use the power function, you have to include math.h. There's all kinds of other that there. So here, this is just there. And note that we are passing a formula to this right here. We're calculating the square root of C1 plus D times F right there. So we're doing the calculation. And here, we're calling square root the function as an argument to another function. So there's two function calls occurring in this one line. Printf is the main function I'm calling. And what do I want printf to print? I want it to print the square root of, of a value, and I'm going to give, and instead of just giving a value, I give it a calculation. So it's a relatively complex formula that I'm giving it there, but it does make life easier. I don't know why these name tags always backwards up there. Now, things get relatively interesting here is that square root can accept different types of data. That there, it can accept double, it can accept integer, it can accept long, it can accept that there. Generally, you have to be aware of what type of data it is right there. But in this particular case, right here, let me say of x and y right here, figure the variable is x and y are type double, and they don't show the figure right there. But again, here we've got a list of some commonly used math functions. Cube root's in there, e to the x is there, log is there, log base 10 is there, a absolute value as a floating point number right there, the rounds to the smallest integer, ceiling right there. For power, we already talked about power, the modulus, and now what is this doing? Right there, sine, cosine, tangent. So these are commonly used math functions. That's just a list right there. So functions allow you to, right there, we've already talked about this. This is right there. Most functions have a list of parameters. That means we're communicating, we're sending data to it. That there. I send my employee to JB to install the generator. I probably have to give them some information, right? The address of where the generator goes, the size generator they need, so we can go pull it out of the warehouse and take it with them, possibly even the names of his assistants. But I give this employee some information. I pass some variables to him. Now this may be in the form of an email message saying, Amin, take Ibrahim and Skanda down to JB and install a 5 kilowatt generator at such and such address, that they're next Thursday and Friday, right there. And then there may be more information. While you're there, stay at such and such a hotel or whatever, that there. So, or the employee may say, all right, I'm going to go to JB, and he goes over to the department secretary and says, can you make a hotel reservation for me and Ibrahim and Iskanda, at the closest hotel to this address? That's on our list, that type of thing. But the thing is that we have to pass information to our functions right there. Right there. Just like we would pass information to an employee on how to do a job right there. It doesn't do any good to calculate the sign of the number if you don't give it the function, the number you want the sign of right there. So in many programs, main is an implementation of a group of calls and functions that there. This is a sign of a good, well-written program, is that main itself has very little code in it. The rule of thumb used to be, and I still try to stick to it, depending on the job. And it's been a little while, since I moved to Malaysia. I haven't done any real work. When I say real work, I'm talking about programming work that I sit down and I write code that goes into a piece of hardware that I get paid money for. I'm not saying that teaching isn't real work, but I'm talking about real industrial work. I used to do a lot of, quote, real work that I got paid for. That's there. So that's there. And as a general rule, when I was doing real work, for industry, you would keep your functions to less than 1 page. If your function was larger than a page, it was too complex, and you should subdivide it into smaller pieces right there. So you try to keep a function itself, and main itself shouldn't be much more than a page right there. Now there may be pages of function headers before you get to main, and there may be all kinds of other stuff. But once you have void main right here, between here and here, this should never be more than a page, roughly, right there. Now, I'm sure the Linux operating system, it might be. Well, they're pretty good programmers, so the Linux world is pretty modular that there. So my guess is it may not be a whole lot more than a page. But the main routine for the Linux operating system could be more, because it's a fairly complex that there. But I'm sure that if you look at the software for the engine control module in your car, it's probably not more than a page. And each of the functions are less than that there. Several motions, divide and conquer. This just kind of repeats the same stuff that there. Again, the whole idea is that third motivation is to avoid repeating code right there. If you write a function, the compiler keeps one copy of the function every time in memory, and every time you call that function, it reuses that same routine in memory. So your code actually gets smaller as you reuse functions over and over again. Packaging code as a function allows code to be executed from other locations in a program, and we call the function right there. So this is a good rule right there, is that each function should be limited to doing one and only one thing clearly. That was something that was beat into my head with a 2x4. A 2x4 is a piece of wood, 2 inches by 4 inches in size that they make houses with up there. When I was at General Electric, Magnavox, we were sloppy about it up there. And Raytheon, we were sloppy. Actually Raytheon got better, once corporate came in. But Magnavox was really strict on your functions did one and only one thing. It was clearly defined and clearly documented right there. And again, the function name should express the task. So if I have a function that's going to read a digital multimeter, I might name it read 3920A DVM right there. That may be the name of my function. So this is going to read a digital multimeter. If I want to set it up, I would have a function set up. 3920A DVM. And I would pass it the parameters that I want to set it up for. Right there. So, and I may, this here may be a little bit wrong. I may have to put a V there. Right there. So, so in other words, read the voltage on a 3920A DVM. Right there. And in here, I may have to have the address of the meter right there as one of the parameters to the function. Right there. And this would say V1 is equal to, and I'm reading a meter at a particular location in a test stand right there. But the name of the function looks very long. Read _V _ 3920A DVM, which means read the voltage from this particular meter. So my computer is talking to my test equipment on the production floor as I'm doing a test right there. So, one of my early, well, I wouldn't say early, I bounced in and out of it through my career, or even as a consultant, work was in production testing, where we had computers out on the floor that tested circuit boards and pieces of electronic equipment during the production cycle. And we would talk to things like oscilloscopes and voltmeters and function generators and things like that in order to do our testing out there. Because we didn't want to pay engineers or technicians to work on the production floor to do the testing. So we had the computer do all the work. So we had a lot of, and we would talk to this equipment using C or The old stuff was old Rocky Mountain Basic, which also used function calls up there. So it's possible is that in other words, if you can't come up with a name or the name is too complex, maybe your function is too complex, is what he's saying here. So, all right, here we're getting into the meat here, and we're going to write a program that the square root numbers right there. And here is our first function that's written. This is a function called square. Now, square receives a parameter list. It receives y right there. And it's going to return the calculation of y squared, which is y times y, right? So what it's going to return is an integer right there. So this is an integer-based function right here. The name of our function is square, and we define it at the beginning, and this is called a function prototype or header. If you look at math.h, you would see that it's nothing but a bunch of these. There's no code there. It's just a whole bunch of function headers right there. And this is before it's called. Normally, you put all the function headers at the beginning of the program right after the includes, because this also is a bunch of function prototypes. Standard IO.h is nothing but a bunch of function prototypes. That's the only thing in there. And then I stick after my includes, I put the function prototypes of the ones that I'm using in my program. Now, quite often, if your project gets relatively large, you might have a separate file that would say the project number.h. And you would put all your headers in a separate file, and you would include that. I worked on one project that was very large, and we had multiple files of headers for that there. So in other words, we had a header file for talking to the interlock system. One was talking to the breathalyzer. One was talking to the PC. We had multiple things going on in this project right there, and we separated all of our functions in the different files that they're of their type. We didn't include them all in the same file right there. So that we had multiple header files right there. But this is a call to includes that they're define all the standard functions in the library. Then any functions you write, you have the function prototype for it, or header. You'll hear the word that in this particular case, he's using int for main. I use void. But if you notice that int doesn't return anything, so we're ignoring whatever. There's no value being returned by main here. Some compilers actually give you an error for that. So, but here, also notice that X, it's called X here, and it's called Y here. Those two names don't have to match. They don't have to match. They can be called anything they want in the calling program and anything you want in the function. Now, what does have to match is the fact that this is an int, and X is defined as an int right there. The types have to match. So I can't say that I'm going to receive a float or a double and pass it an integer. In most cases, you want them to match. There are exceptions, but you want this int to match this int. This line here, and I'm getting too much here. This line here and this line here are typically copies of each other, with the exception that this has a semicolon at the end right there. So typically when I write a function, I write the function and then I copy the first, the copy this line up to the top and just put a semicolon. That's the way that I normally generate my header files right there. So, and in all honesty, this Y doesn't have to be there. It can be just int right there. And I can put the Y right there. You don't have to name the variables in the header, but you just have to define the types right there. So this is a very simple function right there. And we're just going to go through and we're going to print the square of x 10 times right there. So we're printf and then we're calling square. And again, printf is also a function call, as I mentioned earlier, right there. So this kind of just repeats the same stuff that I talked about earlier, that the return passes the value of the, what the function's calculated. Pretty much any function you write should have a return to it right there. There are some exceptions that there. And the exception might be, for example, scanf, we pass it the address of the data we want to receive, so we're not looking at the value of scanf, but in actuality it does return an error code if there was an error that there. But regardless, that there, typically most functions you write will have a return at the end, and that's what we'll return and use that value right there. So this just simply goes in that there. Return value function type, this is the format. This is what the function is going to, this is what the function is going to return. That could be an integer, it can be a char. If it's a string, it's a little bit different, that there. But for right now, we'll just stick to numbers. We have a name for our function. It's got to be unique, and it can't be one of the names that's already used. So if I write a function called printf, for example, it's going to replace the printf in the library in my program. Now, sometimes I want to do that. That's there. Is that I'm running code that I want to use. I don't want to use a printf in the library, but I want to write my own printf, because printf needs to talk to an LCD versus a screen right there. So that there. So, but generally, you avoid putting an underscore in the function name, because those are reserved for things in the library. And then your list of parameters right there. And then this is just executable code is what goes there. The last line of most that there, and it could be elsewhere than the last line, usually is a return. So we call a function, then we return back. And I don't know why my pen is doing this thing, but when I say y is equal to square x, what happens is down here I have int square, and I'm going to say int, and I'm just going to say k, just to be different right there, just to highlight the fact that there. And I've got some code right here, and I'm, let's say I have other code, it's more complex. I'm going to return k times k. Now, I put a parentheses around here. You don't need the parentheses. You'll also find some people will do it this way, and this is completely legit, is they'll say that square equals k times k, and then, instead of that, that's there. And that does the same thing, is I assign the name of the function equal to something, and the normal accepted way of doing it is using the return statement. That's the way that normally you use it. But C allows other ways of doing it. So I mentioned void, that there. So, or sometimes referred to as the function header. I mentioned, again, I use the word header more than I do prototype. I guess prototype's the right term, but the term function header right there. The return value, function name, and parameter list are sometimes referred to as the header. That's the first line, and you need to have 2 copies of that. One at the actual function itself down below, and that's there, and that's shown here. Here's my header right here, right there. That's there. Note that there's no semicolon here. And then you have another copy of that same line with a semicolon at the top. That's there. And normally you have all the headers at there. Now, I hesitate to confuse you, but if it's possible not to have the header at the top if you define your function before that. And when I was first learning C, I hate to say this, but I didn't learn it in a class. I learned it by using it. And I spent a lot of time trying to order my functions in a certain way that they would work and not give me errors before I discovered that I could write function headers and just stick them all at the top and not worry about what order things are. And then, of course, I finally got a hold of a good book and sat down and realized, all right, I should write main first and all the functions should follow underneath main. That's the order. But when I first was learning C, when we first switched over from Rocky Mountain Basic to C for programming our test stands, none of us knew C. So we had a lot of test engineers that didn't know C at all. So we just learned, with a book and trial and error. That's how I learned C the first time. And I can guarantee you that C will probably not be the language that you'll be using 5 years from now. It may not be the language you use the day you graduate. You may find yourself using, Java. You might find yourself using some language that's yet to be introduced. That's there. So there might be some language out there called, programming Baru. They may call it. Their Java was named after an island in Indonesia. So maybe there might be Penang, maybe the next language right there. Just throwing it out there. Actually, Java was named not necessarily after the island, but the coffee. There's actually a language out there for a while called coffee beans. It kind of disappeared quickly, but there was a language called coffee bean. That's it. Okay. I don't know how I'm doing on time. Oh, we got plenty of time. Right there. So, I wanted to get through most of this, what's important on writing definitions today. Right? Okay. So, function name is any valid identifier. It can be of any. You can use any name you want as long as it's not a reserved word or keyword. So, at their return value type is the data type that you're going to return. Normally, for right now, we're going to stick to numbers. If we have a type void, means it doesn't return anything right there. So, and these are called the function headers right there. Error check. If you have a type listed in the name of your function right there, be sure you have the return right there. Be sure that this is of this type right there as well. So we have to assume that there should be some int x in our function right there. And we can declare variables within functions right there. We haven't got to that point yet there. Parameter list is a comment that there. So again, if it doesn't receive that there, a type must be explicitly listed for each parameter. So you can't say, and I'm going to call power, for example, power. We'll call it something different here. Int x, int y. There's supposed to be a space there. I can't say int x, y. I can't do that there. I can do that when I declare variables elsewhere, but in function headers, you have to declare a type for each parameter in the list right there. And believe me, I've made that mistake many times early on. Still do it right there. Because you get used to, you know, I'm a lazy typist that there, especially, I post-stroke, because typing is not exactly easy, that I try to, so I do my int, and then I list all my integers with commas that they're at the top. And you can't do that in function headers. Right there. Right there. So, that there. And again, common error, this is, again, that's what I'm talking about. You can't do that. Right there. Int x comma y. Right there. Place it that there, semicolon to the right parentheses, closing the list of parameters. That's common syntax errors. And that's because at the top we have our int square. I'm just going to use s right there, and we put the semicolon there. Then down here, blah blah blah, we also have int s, our parameter list right there. Usually some comments there, and then we start our code right here, right there. And because you put it at the top, a lot of people think you put it down here. So you have to put the semicolon at the top, but you can't have it at the bottom. That's it. And remember, these two lines are copies of each other. So there's a tendency for some people to write the headers first before they write the code, which is perfectly legit. That there. If you can write the headers first, or you can write the code and then do the headers. Usually I do the header as I'm getting ready to write the code, and then I copy and paste it to the top of the program and stick a semicolon on it at that point, right there. Reproduce as a local variable in a function, that there. So this is a little complicated, but it's one of those cases where here, do not, for function arguments right there, the corresponding parameters in the function definition. That there, you have to be a little bit careful. That up here in main, right here, void, and I have an int x right there. And then here in my function down here, int square, right there, and I have int x right there. What gets really, this can cause some real heartache, because this int is not the same as this int. They're two totally different places in memory. This int exists only during this function call and then disappears. So this x. So if I change x in this function, it doesn't change x in the main routine. It only changes it in that function. So you're better off to use a different value for it in the function, so that you keep that clear that these are different, two totally different variables. So although it's incorrect to do so, do not use the same names for function arguments in the corresponding parameters in the function. That there. It can get really confusing. I mean, there's nothing wrong with it. The compiler will do it. It will work. But sometimes you will get yourself into some serious trouble right there. So it's just one of those cases that's really a better idea to use new names within the function. That there, use new variable names within the function right there. Then the function block, that there variables can be declared in any block. Blocks can be nested. You can't define a function within a function. All functions have to be defined outside that there. And parameter names that there. That's why this chapter is so long. All these little one-line slides, right? The person who generated these slides must have gotten paid by the number of slides that there. You know, I've generated slides for that there, and they tell me that they want 30 to 40 slides per chapter or something like that. That there. This person must have got paid by slide, right there. That there. This is a good observation, though. I'm going to stop on a couple of these. A function requiring a large number of parameters might be doing too much. If I've got to pass it 20 parameters, that function's too complicated. Remember, my rule of thumb is a function should never be more than a page long. It should be as short as possible. And if a function has to do something very complicated, then it can call other functions right there. Break it up into smaller problems. The shorter your functions are, the better, and the clearer they are, the better. They should do one thing and one thing only right there. So just like when you're cooking it, baking a cake, you can't be adding the wet ingredients at the same time that you're doing, that you're setting the oven. Some people will try to do two things at the same time, and younger people get away with it better than us older folks. But the thing is that you do one thing at a time, and you make sure it's done correctly. And the other thing is that if you're doing one thing in a function, it's easy to find errors when you generate errors, because the errors are going to be isolated to the one function, right? So the function prototype, function header, and function call should all agree in number, type, and order of arguments and parameters, and in the type. So everything's got to agree with everything right there. So, I make it simple because I just do a copy paste on the function, the function header up to the prototype that there, I call them both headers, but I just do a copy and paste. So I know that those two agree. But when I call y is equal to sign x, we know that x is going to be of type double, and y is also of type double, right there. So in this particular case, I'm using sign from the library, but if I wrote my own version of sign, right there, everything has to agree, right there. So there's three ways to return a function call. If there's no value, you just hit the word return. It returns back. We can return an expression, right there, the value, that there, and does not return the result, is simply reach. Okay, so in other words, if you just reach the end of the function and you don't have an end, it'll return back, but it won't return anything. That there, they don't talk about the, or you return the expression right there. So main used to be, we always put return 0 at the end of that there. Standard C now does that on its own, so they've removed it. It used to be main always had to return either a 0 or 1 or -1 or something out there to say whether it worked, the function worked properly or not. Now if the function, if main exits properly, it will automatically return the 0. That's built into the language right there. You can also return non-zero variables for your main. Those are helpful for if you've got a problem and there's a crash or you're getting that there, you might want to see what's going on that there. So this is an example right there. I'm going to not require it, but I'm going to suggest that you go through and do this particular one because this is an interesting one. Here's our function prototype. but not before Tuesday. Tuesday, you've got the other problem to worry about, right? That's there. We've declared 3 variables, 1, 2, and 3. Number 1, 2, and 3. We enter the 3 variables. Again, we're calling the function printf, and we're passing it the string enter 3 integers. We have scanf, and we have %d, %d, %d. You can put a space between those %ds. It doesn't make any difference. I probably would, just simply because it's a little more readable. That's there. And we pass it the address of number 1, number 2, and number 3. So that's going to go and read the keyboard for those 3 numbers. So I can type 1, 2, 3. And then printf, the maximum is, and here we're doing a call to the function maximum. Maximum is defined as a function that returns an integer, and it receives 3 integers. Now again, it's a bad habit to get into, but you're going to look at code at some point where someone's not going to have this X, Y, and Z. They're just going to have int, comma, int, comma, int. That's okay in the prototype at the top. But when we have the header, we have to define what they are. Since to save myself typing and to prevent errors, I do a copy paste. My prototypes almost always match exactly as my header. That's there. So one of the things you want to make sure is that you don't change the order if you do that there. In other words, don't do int y, int x, int z at the top, and then down here do x, y, and z in that order. Keep the order the same. Right there. So here we have some code. If int max is equal to x, so we initialize a variable max there. That's a local variable. It's of type integer, and we set it equal to x. And we say if y is greater than max, then make max equal to y. If z is greater than max, then make max equal to z. So we're just comparing the two that there. We return max right there. And that's a relatively simple function, and that's the the easiest way of showing how a function works right there. Right there. So right there. Function prototype. That there. Early versions did not. There was caused properly without the compiler. Yeah. See, I started using C with Microsoft C 1.0. So I'm an old guy, so I remember the very first version of Microsoft C. That there. So as a result, a lot of these early versions didn't do some of the things the current versions does. That there. So we ended up with some interesting errors because some of the early versions didn't work. I told a story about the one function that returned the wrong value. That there, the function had an error. So some of these early libraries had some issues right there. So include right there. Again, this just simply says that this is going to return int and receive 3 ints. It's just repeating. There's a lot of slides, but as I said, I've gone through over a fourth of them. That there, compilation errors, function call doesn't match the prototype. That there, an error is generated, function prototype and disagree. In other words, the header and the prototype, I call them both the headers, but they have to agree with each other. So in this particular case, someone screwed up and put the word void instead of int, and down inside the function where I actually define the function, I used int. The compiler will say, hey, there's a problem here. That there, they don't match right there. So unusual conversions that there. Now this is kind of an interesting one here, is that we're passing an integer, 4 is an integer, and it's going to calculate the square root of 4 right there. So even though square root expects to receive a double, it will accept integers and do the conversions within the function. Right there. Not all functions do that prop very well. You got to be careful with that there. And I'm not going to get into detail right there. Square root automatically convert double without changing. So, however, if it's expecting to see an int, it's going to truncate it. So you got to be careful. If you're sending something to a function that's a different type, the compiler will try to convert it to the new type that's there. So if you go long double at there and it got there, and they talk about there, and we're getting into these are all of our various types that we've got. We've got the long double that's there, but notice that that's an LF, capital LF. We got the double, which is a float. And notice that float for printing is the same, %F. For scanf, it's LF right there. And we've got all kinds of integers up there. I have never used an unsigned long int. That there. That there. And I've never used long int. I've used unsigned long int, and I've used long int, and I've used unsigned int, and I've used unsigned short. Some of these are duplicates of each other right there. So these are all there up there. And this just actually square returns. Now, in our particular case, we declared square as a receiving an int, and we pass a floating point, so it just truncates the at there. Because when we wrote square, it received an int and returned an int. That's going back to the program much earlier in the class. And then we turn right around and we pass a floating point number. It just truncates it. Out there, which is not what we wanted. You know, if we want the square of 4.5, then we should have wrote our square function to receive a floating point number and return a floating point number. We wrote our square function to receive an integer and return an integer. So when we pass it a floating point number, we get the wrong result right there. And I can see, looking at some eyes in this room, I don't know how I'm doing on time, but I'm seeing some eyes starting to float right there. Yeah, we're at that little over that hour mark. That there. I know they schedule